Hello everyone. Long time never post the video because I'm busy. So okay, let's continue. Today's my topic is basic SDH. So basic concept and principle of SDH synchronous digital hierarchies. Synchronous digital hierarchy is a transmission protocol using in telecommunication network to deliver high-speed, reliable data transport. It operates over optical or electrical medium, and it structured to affect essentially handle multiple data streams. So we go next is interaction. So SDH stands for Synchronous Digital Hierarchy, a standardized protocol for transmitting digital signal over optical fiber and the other medium. It is widely used in telecommunication network, particularly for carry a large amount of data over long distance. SDH is similar to the SONET, synchronous optical network standard used in North America, but has some different in implementation. So the synchronous digital hierarchy is an international standard technology for transmitting digital signal over optical and electrical network. The introduced by International Telecommunication Union, Telecommunication Standardization Sector (ITUT). SDH was designed to overcome the limitation of older systems like the piezochronous digital hierarchies, we call PDH. It widely used in telecommunication to provide high capacity, reliable, and efficient data transmission over long distance. So, what is SDH? SDH is a transmission protocol that organizes data into a hierarchical structure, enabling the efficient and synchronized transfer of multiple data streams, and it operates primarily over optical fiber network, but it is also compatible with electrical transmission system. The standard is modular, allowing integrate our various data types such as voice, video, and data into the unified transmission system. Okay, so why was SDH developed? So as you know, before SDH, telecommunication industry rely on PDH, which had several limitations. One is about synchronization issue and flexibility, limited bandwidth scaling. So here, that's why SDH was developed. So we come to the core feature of SDH. Core feature of SDH. The first one is a synchronous transmission. All data streams are synchronized to a single clock source, ensure precise timing and reduce delay. And the second is scalable data rate. SDH support range of data rate starting from STM1, we can say it's 155 megabit, and scale up to 40G, and STM 256, or higher in modern implementation. The next one is multiplexing. Multiplexing combines multiple low speed into the high speed high-speed stream while maintaining the integrity of each individual signal. And the next one is an add and drop multiplexing. Enable the additional or removal of specific data stream without disrupting the inter-transmission, offer flexibility in the network design. And the next feature is error detection and correction. Built-in mechanism ensure that data accuracy and low error rate. And the next one, compatibility. SDH is backward compatible with the old system like predate and forward compatible with modern optical technology. And the next feature is high-speed data transmission. SDH support high data rate starting from STM1 up to multi-gigabit per second. And the last feature is flexible. The structure is modular, following easy addition or remove low capacity stream without interrupting entry system. Okay, we continue with the key benefit of the SDH. So the first one is high capacity. SDH efficiently handle a large amount of data, making it suitable for growing telecommunication demand. So the second, reliability. It provides a robust mechanism for fault detection and recovery, ensure the continuous service. And the third, flexibility. Its modular design allows easy network expansion and integration diverse data type. And number 4, global standardization. As an ITU-T standard, SDH ensures compatibility and interoperability across international networks. So the last one is efficient network management. Centralized control system simplify monitoring, configuration, and maintenance. So here are the 5 key benefits. So next is we talk about the structure of SDH. So SDH use synchronous transport module, or we can call STM. As it is basic building block, each STM signal carry a content combination of user data and overhead for management and error checking. So the hierarchy as below. STM1 is the 155 meg, and STM4 is 622 meg, and STM16 is 2.5, STM64 is 10 gig, and STM 256 is 40 gigabit. So Delaware provide Delaware provide flexibly different applications from small local network to the large international backbone. So STM1 basically basic unit we can call basic unit of SDH, and STM4 is 4 times and capacity STM1, 4 times the capacity of STM1, and STM16 is 16 times the capacity of STM1, and STM64 high capacity data transport, and also STM 256 for extremely large scale network. So each STM signal provide into the smaller container that carries specific payload, enabling multiplexing of different data type. So the next is we talk about how SDH works. So here we have 4 points. First one is multiplexing. SDH combine multiple low speed signal, for example, voice, video, and data or data into signal high speed signal. This is achieved through by by interleaving data is organized fixed time slot, allows synchronized transmission, and for the container, each low speed signal is placed into the container. For example, C12 for 2 megabit signal. And point number 2 is synchronization. All signals in SDH operate in the synchronized manner using a master clock for timing. This avoids the delay and discrepancy common in older systems like PDH. And number 3 is add and drop multiplexing. SDH support add or drop specific data stream without affecting the rest of signal. This is done using ADM, add and drop multiplexer, making it effective for branching out data of data. And the last one is error checking. So SDH employ advanced error detection and correction using priority bit and deep interleave priority to ensure data integrity. So next we talk about the key concept of the SDH. So here we have several key concepts. One is a generator. Generator is like amplify and clean up the signal to maintain its integrity over long distance. And point number 2 is add and drop multiplexer, we call ADM. It enables insertion or extraction of specific data stream. And point number 3 is network management system, or we call NMS, providing centralized control, monitoring, configuration, maintenance the SDH network. And the last one is a cross connection system, allow switching of signal between different network parts for flexible and redundancy. And the next one is application of SDH. So here we have several application. The first one, telecommunication. Backbone infrastructure for voice and broadband service. So in telecommunication, we use for the backbone infrastructure and for the voice and broadcast service. And for the corporate network, supporting secure high-speed data transport for business. And for the media and broadcasting, handle high bandwidth requirement for video and audio transmission. And for the critical infrastructure, using in military, healthcare, and energy network for reliability. And for the enterprise network, large business use SDH for secure and scalable data transport. And for the data center, transfers passive value of data between center. And for the video broadcasting, handle high bandwidth requirement for TV and streaming. And for the military and government network, secure robust communication. And without for the without transmission, high capacity data stream can support video conference and broadcasting. And the last one is the data network, used in corporate network like the ISP and data center for reliable data transport. So all these are the application of SDH. So the next we talk about the advantage of SDH. So the first one is high data transmission speed. For scalability, SDH support high-speed data rate support starting from STM1 to STM 256. And for the capacity, it high capacity make it suitable for application like broadband internet, without streaming and large-scale enterprise network. And second, synchronization, unified timing. As they use a single clock source to synchronize all data stream, ensuring precise timing and reducing delay. And low jitter and wonder. Synchronization minimize timing variation, jitter and drift wonder, ensure the high quality data transfer. Flexibility in data multiplexing. Efficient multiplexing. SDH combine multiple low-speed signal into a single high-speed stream using bi-interleave. Each signal retain identity, allow for easy extraction. Add and drop multiplexing device data stream can be added or removed from the network without stopping the other stream. Enabling flexible and dynamic network management. And point number 4, reliability and robustness. Automatic protection switching, we call APS. SDH network have built-in redundancy mechanism to reroute traffic automatically in case equipment fail or line interruption. These ensure minimal downtime. Error detection and correction. Advanced error checking method such as bit interleave ensure that data integrity enable correction of minor transmission error. And point number 5, standardization and interoperability. Global standard SDH is international standard protocol ITUT, ensure the compatibility across different equipment and vendor worldwide. Backward compatibility. SDH integrate seamlessly with other systems like PDH, making it a practical choice for upgrading latency network. And point number 6 is simplify network management. Centralized control. SDH network can be monitored, configured, and maintained through the centralized network management system. Simplify operation. For localization. SDH provide detailed information about error and fault, making troubleshooting faster and easier. Sorry. Scalability. Point number 7. Scalability. Support for high data rate. SDH is designed to scale high data rate, such as STM64 is 10 gigabit and STM256 is 40 4 gigabit, making it the future ready for increased bandwidth demand. Modularity. Its modular structure allows for the gradual expansion network capacity such as need. And point number 8 was versatility. It support for diverse service. SDH support wide range of service including voice, video, and data on a single network. Compatibility with IP network. While not natively optimized for IP traffic, SDH can carry IP traffic using encapsulation technique like MPLS. And point number 9, high efficiency. Bandwidth utilization. SDH efficiently utilize bandwidth by eliminating synchronized issue. Ensure that full capacity of network issues. Low overhead. Compared to the older technology, SDH introduced relatively low additional data overhead for management and signaling. And point number 10, long distance transmission. Signal regeneration. SDH introduced mechanism to amplify and generate signal, ensure data integrity over long distance. Optical fiber capability. SDH is optimized for optical fiber, enabling high-speed, high-capacity data transmission with minimal loss. And point number 11 is built-in redundancy. Self-healing network. SDH can detect fault and reach and switch to backup path automatically, ensure uninterrupted service. And for the protection scheme, we have 1+1 protection. The application is sent over the backup path for immediate switchover. And 1-to-N protection. One backup path can serve multiple primary paths. And point number 12 is wide application. Telecommunication. Backbone network for a telephone system and broadcast service. And for the enterprise network, secure and reliable connection for large business and data center. And broadcasting, high-speed transmission of video and audio signal. Critical infrastructure used in defense, healthcare, and utility sector due to its reliability. And point number 13, security. Control access. Centralized management make it easier to secure the network against unauthorized access. Physical security. SDH network, essentially over optical fiber, are less prone to eavesdropping compared to wireless network. And the last one is easy integration with modern technology. DWDM. SDH work well with dense vulnerability multiplexing, which enabling multiple SDH stream to be transmitted seamlessly over a single fiber. Ethernet over SDH. This technique can be used SDH query Ethernet traffic, extending the life of SDH network while adapting modem demand. So come to conclusion for advantage of SDH. SDH has played a transformative role in telecommunication due to its reliability, scalability, and efficiency. While newer technology like the DWDM and Ethernet have emerged, as SDH remain relevant in latency, network, and application, require robust and synchronous transmission. It is our solidity and reliability make it is a critical technology in history of digital communication.